All right. Good morning, everyone. Welcome to the TU Eindhoven. My name is Hajo Reijers. I will be your host for the day. It may very well be that some of you do not know me, and I think that's totally explainable. There was a contest this year in the Netherlands for the BPM Personality of the Year. And I ended second place, and that's a tragic position because nobody remembers second place. Just think about the Football World Championships, 1974, 78, 2010. Nobody knows second place anymore. Anyway, I will be opening the session, which is a special session, of the European BPM Roundtable. If there's one thing that I learned over the past 10 years, when I was lecturing here, but also giving talks at conferences and all these things, is that you should never grow too excited when you see a full lecture hall like this, because it may be that people are in the room who are actually not coming for the topic that you are talking about. So I want to clear that immediately with you. We're going to talk about BPM, but for those of you who think that's going to be about trance, dance, dubstep, beats per minute, that's not what we're going to talk about. I see nobody leaving, that's a good sign, okay? We are going to talk about business process management, and business process management is a discipline where the business process is actually a very central artifact, and through analyzing, studying business processes, we gain a better understanding of these things to ultimately make them perform better. And in this discipline, there's a range of techniques, methods, tools, technologies that play a role, and I'm sure that today we will see many of these. We have been organizing sessions like this one in the Netherlands for the past 2 years, and typically we have sessions where, just as we are experiencing today, sit together in a room, hear about new developments in all kinds of areas with respect to all kinds of application domains. So you see here pictures of talks on on visualization, a talk from people from the municipalities in the Netherlands, how they use business process management in their day-to-day work. And you can also see a picture of a more hands-on type of session, where we often invite industrial experts to try out new tools, new concepts that we have developed here. But we do more things than meeting just here. We also have, for example, online experiments, or we have surveys. If I'm right, today you will be asked to participate in a survey on process harmonization. So when you get home, there is homework for you to do. We always hope that you will participate in these things. But as I hope you will see from all these things, we have a very lively community of practitioners and academics working together on business process management. And actually that fits. BPM is a field where research and practice are going hand in hand together. And that is also, I think, the reason that we are here today. Because what we are doing today is we are lifting the let's say the cooperation that we have here in Eindhoven, which is taking place in many other locations in Europe. We're lifting that to a European level. So what we will be seeing today is a host of speakers coming from all kinds of countries in Europe. We have more than 20 cluster nodes in the European BPM network, and 8 of these clusters will be presenting here today. You are seeing here that we have representatives from Münster, from Ulm, Vienna, Vaduz in the Principality of Liechtenstein, Trento, Valencia, and Haifa. And if you stay until the end of the day, you will also hear about from people from Eindhoven. Okay, I'll walk you shortly through the program. We are right here now at the opening. And the first talk will actually be the talk from the people who traveled the farthest. We have Yaron Denekamp here and Arturo González Ferrer. a very Israeli name, I admit that, from Haifa. And after that, I think we all need coffee. Not because of the interest of the talk, but of course we like to start because we have a full program before us still. And then we will switch. We have, unfortunately, we only have Professor Reijers, but he will, I'm sure, talk about exciting things he has done in the automotive domain together with Daimler. The Daimler representatives will not be here, but I'm sure he has plenty stuff to talk about and fill this slot for you. We will then go to Italy. You will hear more about process mining and preparing that activity, and then we will have lunch. All the coffee breaks and all the lunch will take place in the room just before this hall, so you don't have to move around a lot during the day. In the afternoon, we have the people from Münster talking about their work right after the break. Then we switch to Stephanie Weber and Stephanie Rindelema from Vienna. We'll have a short break again, then we will have 2 short talks. First short talk will be from our guest from Spain, and the second talk will be from Teresa Schmiedel from the University of Liechtenstein. The last talk for the day will be a joint presentation by John Hoogland and Wil van der Aalst. They will end the day, and after that we hope you will stay around for a reception where we have drinks, and that will again be in the hallway just close to us. So one thing that we will do is, because it's such a full program and there is so much to talk about, what we would do is we will give the speakers the opportunity to fill the slots, tell everything they will talk about, so there will be not much opportunity to interact in the hall, ask questions and such. But what we hope that you do, of course, is that you, when you hear something interesting, that you, during the breaks, during the lunches, you find the people that you want to talk with, because they're very open-minded, I can assure you, and they'll be happy to talk with you. Okay, for those people who like to be online, there is a guest network which is available. Please use these credentials. I will keep them here for a little bit more time so you can take note of them. If you forget about these things, you can always contact me or other people from Eindhoven and we will help you again. Yes, most things are noted down. Okay. Then, there's nothing else for me to say then. Enjoy your day, and I'd like to give a hand to the first speaker. Connection. Yeah. Okay.
Still? Can you hear me? Yes. Okay. Goedemorgen. And thanks a lot for inviting Arturo and me to talk to you today. And although this is actually the topic of us, I will more discuss the need and challenges in implementing clinical decision support systems. And then Arturo would go on and tell you about a specific solution for one type of clinical decision support with an application for oncology. A few words about myself, because the other one works as well. Okay. Just have to choose. This would be better. Okay, so basically, I'm a physician. I'm a specialist in internal medicine with a subspecialty in medical informatics. I completed a program in this field at Harvard in Boston. And my position today is that I'm a Chief Medical Informatics Officer of a healthcare organization, which I'll shortly describe to you. And I'm a member of the Faculty of Medicine at Technion in Haifa. The headquarters of this organization is in Tel Aviv. And okay, a few words about the organization. Although we're not a big country, as you all know, this really is a big health maintenance organization. We're the largest healthcare provider in Israel. We insure 4 million members. That it's over half of the population in the country. We're of its type, actually, it's the second largest organization in the world. We manage 14 hospitals and 1,400 clinics all around the country with this number of employees and more or less like 10,000 physicians. And we use a variety of clinical IT systems, whether it is an electronic medical record system for the community or several systems at our 14 hospitals and several BI systems. You can see these are the 14 hospitals all across the country, and this includes a children's hospital, cancer center, and rehabilitation centers. And what I want to talk in my time frame is first to discuss the questions, why do we need to be supported? I mean, physicians are like me, we many times we tend to think that we know everything. So should there be an effort by the BPM community or others to find solutions or methodologies to support us? And then I would go on, talk about types and examples of clinical decision support systems, and lastly, opportunities and challenges of implementing these systems. By the way, how many of you in the audience are from the medical domain? Physicians or others? Okay, great. Look at this slide. Statistics that rank the reasons for people, for patients in the Western world for death. So obviously, as we all know, heart disease it's ranked in the first place. But look what causes in the 5th place, medical errors. Okay, and how many of you do know this data or these statistics? Okay, just the 2 physicians. I see that you're worried, me too, and I think all of us should really be very worried. Because somehow as a healthcare organization, something is wrong. We're not performing well enough. And just to say that when we're talking about medical errors, we're not talking about side effects. I mean, if as physicians we prescribe medications, we know that there might be side effects, but we're talking about preventable errors, which means the knowledge exists, but somehow the professionals didn't use this knowledge when taking their clinical decisions, like prescribing penicillin to patients that is allergic to this medication, okay, or dosages, or not taking into account knowledge about drug-drug interactions, not doing well the work of diagnosis, giving the wrong medical and surgical treatments. These are errors. And actually, just show some scientific data about this thing. So several researchers tried to understand this information gap and needs and measure it. So in several studies, it was shown that physicians, whether it's in Los Angeles, one study, or in Europe, so for every 3 patients, actually, there were 2 unanswered clinical questions, and it holds across primary care physicians and specialty care, and urban and rural, which it means that it's not just in the rural areas, far areas, but also in the academic medical centers. And actually, then in these researches, they try to analyze. Okay, a physician had a question, he didn't know about some clinical aspect of the patient that he saw. So what did he do with that? So we expect that, okay, in the end of the day or in the middle of the day, he would go and find out and look for the information. But as we can see in this slide, actually, it doesn't happen a lot. 70% of the times, the answers were not pursued, which means the next day, the same patient with the same clinical question and the same error, the same mistake. Obviously, when physicians were asked why didn't they bother to look for the missing information, so they're busy, they have no immediate access to resources, their office materials are in disarray or are not updated. Okay, and just to talk in numbers, I have so many data, but really just try to show you some more concrete, specific numbers. So the outcomes, one of the outcomes is more or less like 30% of the children receive excessive antibiotics for ear infection. It's an overuse. Look at the number for unnecessary surgical procedures, and half of the x-rays done for back pains are unnecessary. Okay, looking from the underuse, the statistics, again, US, Europe, shows that 50% of elderly patients don't get necessary immunizations in winter. So hopefully you're starting to be worried like us, the physicians. We have a problem, we need solutions. Here we see a study about the causes for a misdiagnosis. As you can see, the three main causes for misdiagnosis, it was published in the very respected journal Medicine, the Annals of Medicine, 2006. You see judgment, memory, knowledge, again. Maybe it's not very surprising if we think about the amount of data, information, and knowledge needed for everyday practice. I think maybe the few physicians here would agree with me and others that I don't think there is any other profession in which for everyday practice you need to take into account so many data, information, knowledge that is updated from time to time. So, okay, and the amount of journals, the books, and the knowledge, the doubles itself every 10 to 15 years. It makes the everyday life difficult, and somehow maybe the public sometimes think that, okay, a physician, they would manage, but we can tell you the truth, the physician, it doesn't work many times. We need to build solutions. And hundreds of years ago, Shakespeare noticed that there is some problem. We can expect people, including physicians, to remember so much things and to use them correctly in their everyday clinical decisions. So we find ourselves, based on looking at the medical record, clinical reports, all sorts of administrative issues that are relevant, and we studied at medical school. We are participating in conferences, we read books, journals, guidelines. This is something that Arturo will elaborate on. And we have to take decisions. And many times, as you can already hopefully see, it doesn't go so well. I like to use this example taken from the economy, actually. Maybe some of you know this. These two researchers, Tversky and Kahneman, actually, they were awarded the Nobel Prize of Economics in 2002. They actually won this prize for showing that in economy, the theory that people are taking rational decisions to maximize their profits, it doesn't work many times. People in their decision process making use what we call heuristics, rule of thumbs. It's not evidence-based, it was not proven. And I like this example to show that also in the clinical domain, many times, decisions are based on heuristics, okay, not evidence-based, not researchers. So, and as their conclusion was that heuristics sometimes are useful, but other times it leads to severe and systematic errors. And this explains, in a way, the data that I'm showing you about the problem. So actually, the Institute of Medicine in the US, following this data that was created, and the researchers about the aspects of quality and errors, there were 3 actually reports. Anyone knows those reports? One was published in 1999, To Err is Human, following it a year after crossing the quality chasm. They didn't call it the quality gap because they thought that the difference between what we want healthcare system to be and where we are is really a chasm. In 2006, they referred to the problem of medication errors and published this report. All the reports actually, one main conclusion was that the key solution to deal with these problems are information technology. Obviously, it's not easy to do, but we must do it, and it is starting. So, just to quote one paragraph from the Crossing the Quality Chasm report. So, if, as for now, still decisions are taken by professionals according to their autonomy, and it's very variable, and decision-based making is based on training and experience, and new rules for the 21st century should be knowledge is shared and information flows freely, and decision making is much more evidence-based. And this takes us to clinical decision support systems. What is it actually? So we are talking about systems that link health observations with health knowledge to influence health decisions by clinicians for improved healthcare processes. And actually, we're talking about active knowledge systems which use 2 or more items of patient data to generate case-specific advice. To differentiate it, okay, if we are, as physicians, if we have electronic, book, or I don't know, some information, like if you know the PubMed or others, so it doesn't consider to be a decision support system because there is no link or automation, at least to data items. We expect the decisions or the systems to generate case-specific advice. And at this point, I would like to emphasize something that in a few minutes I'll describe as a challenge, and Arturo will refer to it. We're talking about supporting, not replacing. So we're, the happy, maybe in the happy days of the artificial intelligence days, that people maybe thought that machines would replace professionals, and this didn't succeed, and it can't succeed. And this is why when planning the methodologies and the system, we should take into account, or you should, wherever you come from, that a physician or professional, we need to be supported. We don't expect machines to replace our final decisions. So what are actually sources of knowledge for the clinical decision support system? When we're talking about evidence-based, okay, maybe it sounds abstract for some of you. So actually there is, when the knowledge is created by researchers, we can classify it according to the level of evidence. I won't get into the detail, but there are methodologies of research that creates knowledge that we can better count of in opposed to researches that were designed and performed not in a very high quality way, and obviously we can't rely on them. So this is the evidence-based knowledge, and another good source, most of the time reliable source for knowledge in the back of the decision or clinical decision support system would be clinical practice guidelines. This is actually created and generated by professional organizations. It can be the European Cardiology Organization, who would publish the guidelines for treating myocardial infarction patients or unstable angina patients, or the same cardiology organization in the US, or the health maintenance organizations, Ministry of Health, and this in specific, again, Arturo will proceed and tell you about this in more details. But, you know, even when the knowledge is reliable and we have succeeded in building a good knowledge base based on evidence-based or clinical practice guidelines, still there is a big challenge. I mean, first, as physicians, whether we're internists, primary care physicians, or others, how can be aware to so many researchers, even if they are reliable, and clinical practice guidelines, there are so many out of the professional organizations. So could we really expect physicians to know about it, to read it? And if they do have the time, and they do read, and we hope them to follow, so many times they are not compliant, because they're not necessarily take their decisions according to the recommendations. So actually, what we expect from the decision support system is to be a bridge between the evidence-based medicine and clinical actions. Or in other words, on the right side, we have the database of the clinical data of the patient. Left side is the knowledge-based, which actually should incorporate the knowledge or the high-quality knowledge. And the inferencing system in between, this is actually the engine, the decision support that creates the patient-specific advices. So if to summarize, where do we need to be supported? Medications, the whole process of ordering medications that are or should be transformed into assignments for the nurses who would collect the medications and are responsible of dispensing the medications to the patients in the hospital departments. It's a multi-step process in which you would have many obstacles and many points in which an error can occur, and it occurs, as we have seen. So this is one important process to be supported. Another one is treatments, how to make us as healthcare organizations and physicians to use most useful, cost-effective alternatives. We know that many times physicians say, it's all right, but why should it be so costly if we can achieve the same target with less resources? The diagnostic process is a complex multi-step process, and there are a lot of institutional administrative processes that should be supported, and I'll be happy to talk about it afterwards since I'm in a time constraint here, so I won't get into too much details. But just think about how many times duplicate tests are done. What for? I mean, it's not good for the patient. Obviously, it's not good for us as a system, and it costs money. Or how to organize well the process of consultations in a hospital. Many times, one specialist is called to another department, and this is quite a complex process that could be supported in order to create more efficiency. Think about labs. I mean, after if it's a blood test, it's withdrawn in the department, should, efficiently go to the lab. I think it's a complex process. And many times there are errors in this process. It doesn't get there, it's not identified very well. You get a result that doesn't belong to the patient, that actually you wanted for him the examination. So talking about types of clinical decision support systems, I'll show you some examples instead of insisting of reading definitions. But we have alerts, which means when, for instance, if a clinical data is abnormal, say the result of the potassium or kalium is very low, so the physician can be alerted, or he didn't follow some recommendation of a clinical guideline, so he can be alerted. You will see it in a minute when Arturo describes the solution for oncology. Type of critiquing. This is an interesting thinking about processes, because a very good point in the workflow to come up with the relevant advice is when the physicians are ordering, whether it's medications or tests, labs, imaging, okay? So if you could come up just there in that specific point and give a useful advice, this is a great timing to incorporate the decision support. And reminders, obviously, as it sounds, to remind clinicians to follow desired practice guidelines and policies. More challenging, actually, and it will take more time for the system to incorporate computer-interpreted guidelines. You will hear about it from Arturo, and expert system, I will mention it very briefly. So talk about interfering or coming up with advices during the process of ordering. One key component in an electronic medical record system is what we call CPOE. CPOE is computerized provider order entry. This is the module that supports the process of ordering medications and other treatments and tests. And it's automatically split the orders, for instance, for medications into assignments for the nurses who would have their task list, and this supports them in collecting, preparing medications, going to the patients, and do the process of medications dispensing. So in this specific moment, it's a great timing to support, and to critique about dosages, if it's too high, too low, per patient, per his age, per his weight, per his renal and hepatic function. I think you know that many times if the renal function is not normal, you should adjust the dosage accordingly. Same with hepatic functions with medications that are metabolized by the liver. So think about all these options, drug-drug interactions, obviously, and others. So just to show you an example, these are, I mean, it has started. There are some systems, still not mature enough, and still we need much more. But just show how a real screenshot. So here, the physician order this antibiotic, to which in the database the patient is allergic, and then he sees this creature, in front of him, and it says, the patient has a definite sensitivity to nafcillin, be aware. Or here, a critic alert for high dose warning, and what I want to show you down here, that it is starting to be evidence-based that it works. Here, they measured before, after. After having this alert in place, it's by the way, it works at the Brigham and Women's Hospital in Boston, So you see a decrease, a significant decrease along the time with prescribing the incorrect dosage for that medication. To just show you the example, what can be done with efficiency. Okay, here, many times, you know, the physicians probably here know that in the clinical wards, we tend to order the same tests again and again. Is it really necessary? So here, if the organization has a policy, you could alert the physician who orders the test and tell him, for instance, here, so look what the physician sees if he tries to order this profile 20. It's a 20 chemical test. So it tells him that according to the utilization committee, it's generally not needed more often than one time every day. Okay. So, or he will be forced to explain if he insists of ordering this test. And this is for a diagnostic. I won't go into the clinical details, but if it's not inconsistent with what is useful for a certain problem, here it's an X-ray of the abdomen, so you could alert and trigger a pop-up window which would actually ask the physician, are you sure? Is it really the necessary imaging for your patient? And talking about cost effectiveness, here you see that when a physician tries to order this test, so it tells him, hey, it hasn't been approved, okay, for this patient, and think once again or get necessary permission for this. It show you just one example for reminders. So here, the system behind the scenes, it checks in the database of the patient, and look what could be shown. Patient has coronary artery disease on problem list, and it checks if he gets aspirin, and if not, so it is recommended, okay, and other things. Just one example out of many. In a research, they tested the impact of reminders for flu shots. It was shown that, it increased, it doubled after this reminder was incorporated into the system. I don't want to spend too much time, but expert systems, these are AI systems that there were really efforts to use it for the diagnostic process, which, as I mentioned before, is a multi-step complex process many times. And there are all sorts of inference methods to use. Just one example, it's a system called QMR, and it tries to support the physician in the differential diagnosis and to tell him according to the symptoms and signs what is, you see the score is a probability for the options that may explain the situation of the patient. Still, it's not a success. Almost no one uses it. There are many problems that should be tackled. One of them is the problem of having probabilities of data, of symptoms and signs, no matter what inference methodology we use. And what is the clinical or modeling and representing the knowledge of clinical practice guidelines. Just one guideline, I won't get into detail because in a minute Arturo will talk mostly about this type of clinical decision support system. So lastly, I would just, am I in time? Okay, 2 more slides. So I would want to talk about the opportunities for implementing clinical decision support systems. So first, to continue the data that I showed in the beginning, we are, as a society, as health maintenance organizations, we are aware to the need. And also, by the way, from the perspective of claims and risk management, it hurts the claims, okay, it costs money, so this is one motivation for the organization to invest in these systems. Second opportunity, electronic medical record systems are increasingly used, including that module that I talked about a minute ago, the computerized provider order entry. And what I think we should all take into account that the decision support system, they can't be a standalone systems. Okay, they must be part of the EMR. We don't expect our users, the professionals, to run from one environment to other. It won't work. So when you're, wherever you're coming, wherever your perspective is, you plan or design a system, think about integrating it into the EMR system, and think that we have more and more platform. By the way, in the US, there is a huge allocation of money, funding for the organization to incorporate these systems. We're using more and more standards, which are key issue for enabling the system to link to the EMR systems. So if actually I need this. So just a short time ago, this was the situation, okay? To really the Tower of Babylon, in terms of the ability to have the data coded, to use terminologies. And what is really changing is that we use more and more controlled vocabularies to represent the clinical data and information, whether in the diagnosis, if you know ICD-9 or SNOMED, or medications, RxNorm, ATC, we have several coding systems, and clinical information model like HL7. One more factor is, hey, we discussed that yesterday, the professionals are less reluctant, to work with computerized system out of the, it was really difficult maybe 10 years ago. It is still, but much or less than it was before. And we have more evidence that it works. And by the way, the fact that we are using more and more EMR systems, it enables to do process mining and to discover improved workflows. And last slide, the challenges are workflow integration on top of the EMR, to find a way to fit it into the workflow, into the process of care, to represent and maintain medical knowledge and process models, to deal with the complexity of modeling time-oriented data, which is relevant many times in the clinical domain. So for instance, if you have two hemoglobin tests, in difference of week, one from another, many times it is relevant clinically. And a need for flexibility, to support, not to replace, as I mentioned before. Ambiguity, many times, if you look at clinical practice guidelines, it's not very deterministic. So it would say, you consider, there are all sorts of words that are really hard to transform into computer interpretable language. So this, again, needs some solution, and there are ways to deal with it. One thing more, let's remind that we can't annoy our users with too much alerts. Then we will easily get into what is called in the medical informatics literature as alert fatigue. I mean, they would just ignore it. So we have to find the correct balance, not to make them hate and not consider anything, and in one way, and show them the really relevant information. Obviously, simple interface directed by the user, and these are the benefits. Actually, we aim to improve patient safety by these ways, improved quality of care and efficiency in healthcare delivery. So actually, as you can see, we have still a lot of work to do. And let me invite Arturo to go on with talking about the clinical practice guideline and to model it, and an example from oncology.
Okay. So thank you, Yaron. I have not too much time left. Okay, so my name is Arturo. My background is in computer science. I did my master in in a program called Design and Analysis and Application of Intelligent Systems. I would try to quickly give an overview of a possible solution that can integrate somehow also the cooperation of different stakeholders in the healthcare domain. So quickly, as Yaron said, I'm going to talk a little bit about formalization of the guideline knowledge. What is guidelines? These clinical guidelines are usually manuals that the physician use, and how can we develop formalism for representing this knowledge. Then quickly, how to enable clinical workflow and therapy planning, and several techniques that can be used for this. And if I have time, the problem of mapping knowledge to data. So guideline knowledge modeling. Many different formalisms have been developed in the last decade for expressing the knowledge that is needed in the management of clinical healthcare processes. For example, here on the right you can see an example with the language glyph on how to manage chronic cough. And you have several different elements like action steps, decisions, branches, synchronization. And of course there are also many things used for a specific representation of temporal knowledge, which is also very important in this domain. Or, for example, proforma is also including a way to rank decisions. I think that there is a main difference with processes which can be more automated. And we are used to this BPM notation. I think that the main difference probably is that BPM already include the possibility to represent roles, participants, how to manage cooperation of different workers. And I think that also would be great if this notation can include more a temporal perspective, because I think it's not very easy to express the semantics of clinical processes. And there are some research about it, but I think if you want to express different time points, interval durations, constraints, this is really important, especially when you are modeling guidelines. So this could be a good opportunity for the BPN to include this kind of expressivity. Okay, so regarding how to enable organizational workflow and therapy planning, we can think of different roles, different stakeholders that are involved in the processes of care. We can think of physicians. You have there several questions that they would like to have support for, like to know if the patients are taking medications, who did what during a process, especially in guidelines. When we are using computer interpretable guidelines, we have a view of a single physician, and I think BPN can be used to again to include cooperation between different stakeholders in the processes. Reminders: don't forget that you need to do a lab test. Also, how can they know if they are following evidence during the treatment, how many times this, they change dosages plans. The patients, they want to have personalized care, reminders, record their actions, probably in a personal record. And you can think also, or probably personalize the care adapted to the insurance coverage. These kind of things could be interesting. Managers could be interested in how in checking if they are running out of resources for a specific period, or how many nurses do we need in a specific week, or if they have a peak of patients at any moment. Of course, if they are following guidelines, how to check if the processes that have been carried out have been checked against the evidence. Okay, so this is a picture from a paper from Richard Lenz and Manfred Reijers, which is the next speaker. A way to this is also from hospitals, a way to model probably to follow clinical processes is a care pathway, which is a way to model a time process, focusing on the patient, but also specifying the events, the clinical exams that needs to be done within the limits of the resources, okay? So it's somehow how to evolve from medical practice guidelines into a pathway that is adapted to the organization. And of course, this pathway can then be adapted to specific patients. But we need to support flexibility, as Yaron said, since this pathway needs to be sometimes adapted to specific patients' conditions. So we will show a way to create automatically these pathways from the specification of guidelines. Okay, this is a possible solution in the field of artificial intelligence, a possible language that can be used to represent the knowledge from clinical processes. I won't get into details because we don't have too much time, but basically is a language which is based in first of the logic. It's declarative in nature, but it's always is also able to express control flow patterns, okay? And it's very good for domains which are based on expert knowledge, like this one, like the clinical one. So to summarize till now, the different technologies are computer interpretable guidelines that are used to model the physician view. BPMN is more used to model the organizational view of the care processes. And the artificial intelligence can use the planning and scheduling language, can use this knowledge and try to provide a plan which is considering not only the physician view, but also the patient view and the organizational requirements. And it can model heuristics to drive the search of the goal plan. So different planning approaches, and which one could be useful for the problem of healthcare. We can see a fully deliberative approach where we think that we can design a plan of process where everything is somehow predictable. Then fully reactive approach when the outcome of the task may not be predicted. Then building processes with conditional branches, like BPM is usually this way. So the branch of being executed depends on the satisfaction of certain conditions. And continual planning is somehow a mix between a deliberative approach and reactive approach, where we can create a specific plan until a specific milestone, And then we evaluate the state of the patients, of the environment again, and try to create or to adapt the plan to a new one. So this is a quote from Eisenhower, which I think is good for healthcare, but also for many things in life. He said that in preparing for battle, I always found that plans are useless, but planning is indispensable. Okay, so it could be like the continual planning approach somehow. Okay, these are very quickly the different techniques that we have developed for moving from BPM and CIG specifications to these declarative processes using HTM planning. The second one is experiment we did about modeling a guideline of oncology with the language ASBRU, which is a computer interpretable guideline, moving to an HTM domain, and then somehow provide recommendations on how to carry out the plan of treatment, considering different resources and also all the temporal specification of this process. This is very quickly the whole architecture of this development. The physicians are in charge of modeling the guidelines. Then knowledge engineers model these guidelines, which are first in text manuals using these languages. Then we can express or create a translation into the planning specification, which can be interpreted by the reasoner to get this pathway, which is personalized for the patient and also for the organization. Okay. Then we can have from this pathway we can deliver the plan. Either we get a plan that can be used in paper by the physician, which already is really nice because they can save a lot of time. They don't have to create a personalized plan reading the guideline. So here in the probably 15 seconds or less, you can have the plan already done. And then we can map this plan into an enactment engine, like BPM runtime engine, or any other which is more adapted to this specific domain. And of course, we need to somehow consider the possibility of adapting these plans. As I told you, and as Yaron said, you need to guarantee the flexibility of these processes. Okay, this is a software created from this research, which is called Corner Care. It got an award in the last adaptive case management contest in the category of healthcare. So the example of cancer is probably a good one for this technology and for showing how can we integrate into the workflow all these requirements that we have. It has a high incidence and prevalence and cost, high complexity. It needs to be somehow based on evidence-based medicine, and needs to be personalized for the patients. Okay, and the patient conditions are changing many times. So what physician needs is to design personalized treatment very quickly, conform to the evidence-based medicine, keep up with the practice guidelines, of course, and to react to these patient conditions. So this is a view of the system running. You can see different drugs that needs to be administered in different cycles, which have a lot of temporal requirements. So, for example, you have to express that the difference between a cycle and the next one needs to be a specific time. And then you have a way, of course, to so that the physician can interact with this plan. The plan is they can see if the drug is administered, or they cancel or remove, or they change the doses. This can be done by the physicians, of course, and they can do, I don't think, okay, they can do different interactions with the plan itself, okay? So they can cancel drugs, delay drugs, or change the doses of drugs. All of this is going to be stored in a log, okay? And they have here a tentative forecast of the treatment, and of course it could be changed because there are intermediate milestones, lab tests where the state of the patient is reevaluated, and the plan can be, of course, readaptive to a new situation. Okay. So with this kind of technology, you can also have a view for managers. Of course, this software have different views for the different roles in the process. The managers could be having an estimation of how many resources will be needed, nurses, doctors, whatever is modeled in the guideline, and how many patients do they have in a specific time period. So they could see that there is a peak and talk with the physicians, look even if they can change the plan. And of course, the plan is always checked with the guideline that was modeled, and they would have alerts in the case that changing patients for one day to the next one would be not recommended by the guideline. Okay, so very quickly, the knowledge to data mapping is one of the problems with modeling guidelines and with integrating with real data. We will see a simile with the good and evil. So if you imagine this is heaven, and this is hell, we could think that physicians' clinical knowledge, guidelines and evidence is really promising, and everyone has a good view of these guys. In the other way, system engineers, data privacy, a lot of vocabularies, control vocabularies, standards, many technical things needs to be somehow integrated with this knowledge, and it's not easy at all, but it's really important to separate somehow. So we need someone smart to accomplish this bridge. So I think that we need knowledge engineering, which is turning the process of constructing knowledge-based systems from an art into an engineering discipline, and we need to use better methodological approaches. So what is the knowledge to data mapping? When we want to model clinical concepts in the guidelines, we need to express very quickly how is a clinical knowledge evaluated to data. So what we want to express here is the clinical concept without relating to data. Okay, the data representations could be really different. For example, you want to evaluate that a patient is pregnant. Everybody knows what is the concept of pregnancy, but checking in a real electronic medical record is really complex because you can find many different things, not what you're expecting, a Boolean field saying if the patient is pregnant or not, but you can find a delivery date, you can find an ACG, lab test, you can find very different things. So this is progress that we are doing in the MobiGuide project, which is also an evolution of previous work done with Yaron, where the computer interpretable guideline needs to be somehow evaluated with the data in a personal health record, And in this personal health record, we will store many different data coming from the patients, also including data coming from medical devices. And after the evaluation of the computer interpretable guideline, we will store recommendations into the system. Okay, so here in this mapping needs to be expressed without expressing technically concepts should be represented differently and not expressed in terms of data here. Okay. Okay. So this is only to finish. I was subject of many jokes because my name is Arthur. I'm coming to a round table. So my namesake Arthur used to say that there is no worse death than the end of hope. So I think there is still many things to do in the field and many opportunities for this kind of systems to provide help to the healthcare people. So that's it.
Thank you. Thank you, Yaron. Thank you, Arturo. With this, we stop the first session. I invite every one of you to have a coffee, and in 15 minutes we will start again with the rest of the program. Thank you.